So, good afternoon. My name is Olivier Rascol, and today is Monday, June 18th, 2012. We are at the 16th International Congress of Movement Disorder in Dublin, Ireland, and it's my privilege to interview Professor Peter Jenner, who is an honorary member of the Movement Disorder Society. So, Peter, as a starter, could you tell us about your background, where you're coming from in terms of educations and...
I'm a bit of a genetic freak, I think, because I come from a very working class background, and I was brought up by my widowed mother. My father died when I was 2, and I was brought up by my sister, and nobody in my family had ever been into higher education before. My mother's family were farm labourers, my father's family were factory workers, and so it was very surprising that I actually went on to what we call grammar school, which is the best secondary school that you can go to. And then I went to university, and it's still not very clear how all this happened, because it's the first in the family.
And when did you decide that you would be interested in science, in biology?
I wasn't very good at school. I didn't do very well at what you would call high school or secondary school at all. I was very average. And then I went to university, and I, in fact, studied pharmacy.
Where was it then?
This was what was called Chelsea College of Science and Technology in its day, and then became Chelsea College. So it was right in the centre of London. And I have to say, I went there, I hate to tell you, in 1964. And one of the reasons I chose to go there, because it was 1964 and it was Chelsea. And I had a number of very happy years being a student in the Chelsea environment, which was great for fashion and music and some study.
Oh. And so your orientations towards neuroscience was driven by which reasons?
Interestingly, that's not where I started at all. So I did pharmacy, and I specialised in pharmaceutical chemistry and pharmacology in my final year. And then I did a PhD in drug metabolism and pharmacokinetics with a guy who was very orientated towards the metabolism of amphetamines, called Arnold Beckett. Except I got to work on nicotine and related tobacco alkaloids, and I finished up looking at metabolism of nicotine, cotinine, anatabine, anabazine, all sorts of alkaloids, which in those days, we were allowed to stuff into literally every orifice of the human body, and then look to see what came out in, largely in urine, because we couldn't detect things in plasma. So that's what I did for my PhD. And then I went on and did a postdoctoral period working for Les Laboratoires Servier. And the plan was that I would go to Paris and I would set up drug metabolism for Servier in Paris. But unfortunately, I had a bleed from my lungs. I had some bronchiectasis. And so I needed some surgery to take out the lower lobe and half the lingula. And so I decided I really wanted to stay in the UK.
Good weather of England.
Absolutely. So things changed. And then I was looking for a job. And I didn't see this job, but my ex-PhD supervisor pointed out that a newly set up University Department of Neurology wanted a lecturer in biochemistry. Well, I wasn't a biochemist, but I could measure things, because that's what you do in drug metabolism and pharmacokinetics. So I went along and I met this youngest ever professor of neurology in the United Kingdom, David Marsden.
Imagine.
And he and I got on like friends from the first instance. And he almost immediately, without asking anybody else, offered me the job. He took me over to Goller Ward, which was where he had his patients, his inpatients, and he showed me somebody with Parkinson's disease. And I just thought, this is so much more interesting than what I've been doing. You know, looking at another piece of mashed up liver, looking for another hydroxylated metabolite or N-oxide was not what I wanted to do anymore. I could see people with real problems, and he explained about Parkinson's disease and about dopamine deficiency. And I have to say, at this point, I knew nothing about the brain at all. I'd never worked in a CNS area, and meeting him and seeing somebody with Parkinson's disease changed my complete direction.
Yeah, sure. He has been funding the society and has been really the mentor of most of us. So that was just by chance that you happened to...
Pure pure chance. And when people ask me about my career, they say, well, it must have been planned. You must have had a game plan for all of this. But I would just merely point out that most things that have happened to me have been complete accidents, that I've just drifted along and things have happened at the right time because I've just happened to be in the right place.
Because one thing that I always admired in you is that you are not an MD, but among the people interested in drug development, you probably are one of those, in my perspective, who has the best understanding of what is clinical pharmacology. And do you think this is coming from David Marsden teaching, or how did you also, got this background for a pharmacist and a scientist?
I sort of picked it up, but Marsden was very good because he was very inclusive. So there was no separation between clinical neurology and basic science in his department. Everybody got mixed in to do everything, and you got exposed to everything. And then I started to meet people from the industry, and I got an understanding of how the industry works and what the industry needs. And sometimes when you're an academic and people come along from drug companies, all you think about is 3-year funding for your laboratory with no outcome. Lots of people don't realize the industry has to produce a product and they have to market that product. And I sort of got that fairly early on. And that was interesting. And I've always been interested in applied things. Very, very basic science has never been for me. I could not spend my life looking down a microscope at a single synapse. But to see things that you can translate into a drug that may improve the life of people with Parkinson's disease, that's exciting.
Yeah, sure. And apart from Parkinson's disease, in your career, have you been also working and dealing with other disorders, psychopharmacology? Or?
Psychopharmacology, indeed. Because we were based at the Institute of Psychiatry in South London, Marsden felt it was important that we keep the psychiatrists happy by looking interested in some things that they found relevant. And the obvious one for us was something like tardive dyskinesia. And what we did was we set up these mega experiments, unbelievable experiments I don't think we do today, where we'd set up colonies of 1,500 rats, and we would treat them with chlorpromazine or haloperidol or sulpiride in their drinking water, and then we'd look for behavioural and biochemical indices associated with tardive dyskinesia. And we did this really quite successfully for a number of years, but those were horrendous experiments to do. But I think they were some of the most cited work that we did in that era, and it did go down well, and we did get an understanding of tardive dyskinesia from those studies.
And do you think this has been important to enrich mutually what you understand or what you were working on in motor disorders, psychiatric disorders, etc.? Yeah?
Yes. I think the interface at the Institute of Psychiatry was pretty stark before we did this, because we had the pure psychiatrists who weren't interested in anything biological whatsoever.
Yeah.
And then there was the biologists, and we started to bridge that gap. We started to bring a biological input into what they thought about. It took a long time to get change, but if you go to the Institute of Psychiatry these days, you see much more. In fact, the major activity is basic science now.
And so, do you belong to those people who understand psychiatry much more like a biological, neurological problem than psychoanalysis?
Yeah, well, probably like that. I don't think I claim to understand any of these things fully. That's for absolute certain. But again, it was the fact that this was a patient-based problem that we were working on, and that's the thing that I liked about working on tardive dyskinesia and other extrapyramidal side effects of drug treatment. And we did do a lot of early work on drugs like sulpiride. We were there very early. We started with metoclopramide as a D2 antagonist that did cause Parkinsonism, and we went on to other substituted benzamide derivatives, and we spent a good decade working on atypical neuroleptics.
Yeah. And well, at the time you were there, you said that David has been, really a pioneer in putting together basic scientists and clinicians.
Yeah.
Was it something very unusual in other fields? Was it very special to David for being creative in neurology in this area? Or in England at this time, were there any other equivalents?
Not really. He was pretty unique, and I think he realised the need to integrate basic science with clinical neurology. I think again the separation between the two when he was appointed. You have to remember he was appointed at something like 33 to be a chair of neurology, which was unheard of in the United Kingdom at the time. This was certainly an older man's profession, or not. I have to say older man because there were very few women involved in neurology at the time, and he started a dynasty. There's little doubt about that. And as you know, many people were influenced globally by Marsden and the fact they worked with him and his writings and his teachings.
And apart from David, I mean, there have been a number of great pharmacologists and neurologists in England, but also elsewhere in the world at that time.
Yeah.
Who would you like to quote or to mention who have been influential or you admire or you have a special thought for them?
I thought about this, and my major worry is I think most of the people I'm going to mention are the people who might watch this video have never heard of, which would be quite interesting. But the Swedes were very dominant.
Yeah, that's
there
true.
was Urban Ungerstedt, there was Kjell Fuchser. I mean, the Swedes were not only beautiful and blonde, but they were great at neuroscience. If you came to Belgium, working at Janssen's were Pierre Ladron and Jose Leysen, who did a lot of the early receptor binding work. If you went to Italy, there of course was the group working in Sardinia. There was Gessa and Di Chiara and Spano, and these people, great people to work with. In Paris, we had what we in those days would refer to as the Agides. We had France Agide and we had Yves Agide as well. Great people. And if you look in globally, then Solomon Snyder working in the US and Ian Crease and Phil Seaman working in Toronto in Canada. It was a very exciting developing era.
And there were close connections between these teams. In this time, now we are at the internet level where everything is immediate. But
yes, I think there was actually a much closer connection than one has today. I think things were much more intimate. I think we were a smaller grouping than we are today. We all knew each other very well. We were rivals. There's no doubt about that. But we met at what I would say were, in some ways, better meetings. There would only be 100 people there. It was a very intimate atmosphere, and you'd spend 2 or 3 days with the same group of people, and you'd have fantastic science, and then the evenings, all of you would go out, and you'd probably eat too much and drink too much.
We'll come to that later.
Yeah. It was, I think, an exciting, evolving era, and now I find it difficult even to get my students to phone people, let alone come and give oral communications at meetings. Everything's done, as you said, electronically. And I find that more distant and less intimate and less exciting, to be quite frank.
So you are among those who have a quite close relationship and interaction between academic and industry.
Yes.
And which is something that is constantly, up and down with pro and cons. And what would be your views on, the benefits you got from this dual experience, and also, would you have any problems or criticism about the interference between the two fields?
Well, the first thing to say is that because I like translational science, because I like things which are applied, you have to be realistic about this and understand that new molecules largely come from the pharmaceutical industry.
I fully agree.
And if you want to be involved in this, you work with the pharmaceutical industry. Then it's the point I made earlier. You have to understand what the industry wants. The industry is not a charity.
Exactly.
The industry is a business. And if they work with you, they usually want something in return. But I think what you have to do is you have to try and keep that in check as much as you possibly can, and keep control of publication of material and the way in which material is handled. But I think you have to expect that they will want to use you at promotional events in the fullness of time. And that's part and parcel of working with industry. I think some of my colleagues, academic colleagues, they're too purist. they would never have a good relationship with industry because they don't understand that it is a business and that it is there to make money for the shareholders of the company. And on the other side, you have to bear in mind that if you're a translational scientist, if you're interested in something that has benefit for patients, this is a direction that you almost inevitably have to go in. It's very difficult to work in isolation in the wilderness. You're not going to produce molecules of your own. And the industry is the only body that has the muscle and the money to develop these from being interesting molecules into clinically relevant drugs.
Sure. And do you think you've been successful in managing keeping your independence and creativity? And did you have good or bad experience in trying to convince these private partners into your ideas, or that they imposed sometimes things that you disliked?
Yes, at times there have been things because it's been too commercially orientated. But because I work with experimental models of Parkinson's disease, because I'm doing it at that level, in some ways I'm a little bit buffered from what might happen if you were doing it at more advanced stage.
The way I'm doing it.
The way if you're doing it more. Yeah, so I'm a little bit buffered from that. But there are occasionally attempts to divert you, to get you to say things that you don't want to say. And I think what you have to do, if you're going down this road, you have to be firm. You have to say, no, this is not what we're going to do. And if you want to do that, then I'm afraid then you have to go and work with somebody else. But on the whole, I would say that most companies are very ethical, increasingly so, and that sometimes they actually pull me back from perhaps saying things that overstate the facts. And it's a balance.
Yeah. And dealing with many of them also put you in a position where you are much more comfortable for saying no to a given one.
You're exactly right. If you are tied to one particular company and only to that company, I think that's bad news for everybody. It doesn't look good. It's not good for anybody. But if you're willing to work with the spectrum of pharma and biotechs that are out there, that's a different story because it shows that you're independent and that you're unbiased. And I think the most important thing is that whatever they ask you to do, give them an honest answer. Don't try and alter things because you're trying to guess what they want. Give them an open and honest answer, and if it doesn't work, it doesn't work. If it doesn't turn out to be how they want it, that's tough. It's got to be that way.
And to close this aspect of relationship with industry, when one is growing up students and successors, I think it's also probably a source of reward to have your postdocs getting nice positions, both academic but also in the industry.
Yeah.
And so, with a number of years looking backwards, do you think that this also has been a nice achievement in your career?
Well, I've had about 65 successful PhD students. A number of them are now professors in their own right. The ones who've been most successful have gone on to be lawyers and to go into the commercial world. But yes, a mixture of people who've gone to the pharmaceutical industry, they've gone into academia, they're in the UK, they're in Europe, they're in the US, and that's great, and that's really rewarding. And I look at the stack of PhD theses above my desk, and you can take some pride in that. And I wouldn't say if I was doing things again, I'd do as many. I might do less, but better, because it's very difficult to supervise very large groups of people on a daily basis when you have a busy schedule doing all sorts of other things as well.
And do you keep close relationship with many of them? Does it create the kind of a network that enrich your thoughts and
yes,
or personal?
Well, you see that this is a very interesting question because I'm not sure I do keep in touch with many of them. The reason being, I'm sort of used to living in this transient world where people come and go and they're with you for a while and then they're gone and another group of people come. And I'll take you back to the beginning. I was sort of brought up almost as an only child. I had an older sister. I was used to being by myself. And my mother was always too busy to spend much time with me. So I got used to this sort of world of managing by yourself and perhaps not needing friends, close friends in the way you do. And perhaps that's why I don't keep up with people as well as I possibly should. Some, very close.
Of course.
Others, after they've the PhD exam, I may never see them again.
And going back to the few decades of your academic careers, I mean, what would you say has been the main challenges, and then what has been the main achievements that you are proud of?
I'd like to say the decades of my academic career up till now.
Yeah, there are many others in the future.
Not too many, I suspect. I think the biggest challenge is getting where you really want to go. And the first
Did you know from the beginning where you wanted to go?
I had no idea where I wanted to go at all. And as I said earlier, a lot of things that happened to me have happened merely by chance, as far as I can see. And I freely admit I'm nowhere near being the best scientist in the area whatsoever. Clinicians look at me as being too scientific. Scientists look at me as being too close to clinicians. So, because I like this translational world, I fall down a hole in the middle between them. But I think I just started to get an appetite for being able to be good at what I was doing, irrespective of what people thought about me. And you sort of have to get used to the idea of a little bit of climbing over the bodies of your colleagues to get where you want to go, because you're never going to be successful if you're too nice about these things. And I'd say that to younger people. You've got to remember that this is a competitive game where the person sitting interviewing me here is probably reviewing my grants and papers, and where he and I are competing for the same money. So, there's a strong element of competition in there. And I just sort of found as I went on, I was quite good at playing that game. And coming from the Marsden stable, I learned quite a lot about how to do that, grantsmanship, telling grant-giving bodies, I shouldn't say this, but telling grant-giving bodies what they want to hear, not necessarily entirely what you want to do. And so that I found, okay, being in a world with clinicians, I found a little bit difficult. Marsden was inclusive, but many other clinicians were not inclusive of basic scientists. In fact, they were exclusive. And they were clearly from a planet that I didn't exist on. And so being able to get them on board and being able to relate to clinicians was a challenge, I think, at first. But one of the things I sort of do quite well is I can take scientific concepts and I can break them down to digestible pieces, and that helps me, I think. And the world has changed now. I think neurology and the movement disorders world has changed dramatically, so that there's more recognition of what's done in the basic sciences. The things I'm most proud of actually are not something really I suppose we haven't touched on. I'm most proud of the stuff we did in pathogenesis. I'm most proud of the fact that we had this idea about complex 1 and mitochondria, that we did free radicals and oxidative stress, that we've done proteasomes. And in some ways, I wish perhaps more that I'd sort of focus more on pathogenic mechanisms in Parkinson's disease, because the way I've always operated is we've always had a broad spectrum of things going on. It's been sort of like a portfolio, that if it's not going well at one end, it's probably going to be going all right at another end. And maybe I spread myself a little too thin at times.
Do you think that, in the past 15 years, maybe there has been so much facilities for the industry to try anything that they wanted to go prematurely into testing clinical applications, and that there might have been a better approach for refining more at the preclinical translational stage, or?
Yes, I do. I agree entirely. If you look at what we do, there's still a lot of it's based around the 6-hydroxydopamine lesion rat and the MPTP lesion primate. And I think there's been a lack of willingness to invest in new preclinical models, not only of motor, But my mission at the moment is to try and get somebody recognise that we need to do more about animal models, experimental models of non-motor symptoms, because as far as I can see, we're not getting very far as that's concerned. And if you look back, if you were being extremely critical in this area, you'd say, well, the best drug for treating Parkinson's disease is half a century old.
Exactly.
What have we been doing for the last half century, and how much have we made life better for people with Parkinson's disease? You know, we can say, well, we've done a fantastic job with this or this, but if you look at the reality of it, levodopa, L-dopa, is coming out still as being the premier drug for treating Parkinson's disease.
Why is it so?
Why is it so? Because we got carried away. We got carried away with the fact that we could focus down on specific types of dopamine receptors, and we went down the road of producing D2, D3 dopamine agonist drugs with a lot of industry and other momentum behind this. But when you look back at levodopa, it's a dirty drug. It's a good classical, these days you would say rich pharmacology, but this is a dirty drug in many respects. And as you know, it's not simply a question of hitting dopamine and hitting D2, D3 receptors. You're looking at multiple dopamine receptors, you're looking at other neurotransmitter systems, and in some ways I think we've made an error by being too focused on one specific target.
I fully agree, and I think that
levodopa.
I'd like to listen to your opinion about good old clozapine or good old amantadine, because they're just about the same time and the same kind of dirty profile.
Dirty profiles, great drugs. Clozapine, probably the best ever antipsychotic drug produced, hits everything in sight. And it's interesting that now when I visit some of the pharma industry and I sit on at advisory meetings, I'm starting to hear them talking about dirty drugs again. I'm starting to hear them talking about molecules with dual or triple actions. And maybe we're going back, because if you look down the road, as you will know, the pipeline for Parkinson's disease is not exactly brimming. We have relatively few compounds in late phase 3 development. If you come back a little bit earlier, we've got not very much at all. And one of the reasons I'm convinced is we became very nigrocentric and very dopamine focused, and we have forgotten that this is a multi-pathology, multi-biochemical defect disorder, and we need to do more than just hit the dopamine system.
Just I wanted to have your opinion on these non-dopamine drugs which are in the pipeline for a long time with good preclinical background, and still facing problems in really reaching the market and demonstrating efficacy and safety. Do you think this is so because it's a novel field and then, you know, it's more risky than copying the 12 dopamine agonist? Is it so because and you have been working most of your life in animal models for translational, do you think that the animal models have limitation, are not predictable, or do you think that this is inherent to these mechanisms?
Probably a combination of all of that. I don't think the animal models that we largely use, the classical models, are as predictive of the effects of non-dopaminergic drugs as they are for dopaminergic drugs, and that's because they are very specific models of nigrostriatal degeneration, and as you know, they don't reflect the pathology of Parkinson's disease. I think the biggest difficulty, however, is that the fact that we discovered dopamine and dopamine deficiency 50 years ago, and that we've had really good drugs for attacking motor symptoms. And in some ways, these days, you have to show that a new drug is doing something which is over and above that which you can achieve with a dopaminergic medication. And that's a tough call for some of these compounds. And for example, we have adenosine antagonists in late stage development at the moment. And I think one of the biggest problems is the challenge they've been given in clinical trial in showing an improvement in people who are maxed out on dopaminergic medication, when the preclinical says something completely different. The preclinical says these drugs work better in a different way, and maybe we haven't understood that. But it could be that we're not going to see the efficacy from these compounds that we've seen with dopaminergic medications. They may turn out all to be adjunctive medications, and you're still going to go on for another 50 years with levodopa. And you took over from your father, and somebody may take over from you in 50 years' time. You may be looking at levodopa again.
Probably, you know, we are used to time frames which are unrealistic in terms of science and evolution. But it could also be that the advantage of playing for motor symptoms on these non-dopamine agents is that their safety profile will be quite different.
Yeah.
And rather than accumulating dopamine load in the same patient, which will generate a lot of adverse events, using these different medications might come to a better benefit-risk ratio. How would you say animal models help us in understanding the safety tolerability profiles for drugs?
You see, this is quite interesting because when people use these models, they only largely look for efficacy. We largely, no assessment is done, at least in the way we've done things, and I know other people do things, to look at the safety efficacy ratio.
Do you think we could do better in the animals?
I think we could do much better.
They could be predictive. I mean, because rats do not vomit.
No, rats do not vomit, indeed.
But they have a number of other behavior that could be predictive.
I have a young neurologist who's working part-time with me at the moment, whose job it is to do a neurological examination of the MPTP-treated primates, because this has not been done in full. If you look at these animals, they clearly have hyperreflexic bladders. We've never looked at their cardiovascular function. We have no idea. They have hypersalivation. They have ataxia. They have gait difficulties. Mm-hmm. We have never fully exploited what we already have. And
they might be also hallucinated.
They might be hallucinated. You see them looking, I probably am on this, looking strangely into the distance. And you say, is this an hallucination? But we haven't done that. We've been almost in a hurry. Everything has been push to try and get these things progressed and into the clinic. And it's not necessarily in symptomatic area that I think the biggest problem. I think the biggest problem is in the neuroprotective
I was coming to that, to the models. Yeah. So go ahead.
Well, as you and I well know, if you go to the literature, we will find probably 100 compounds which work in the MPTP-treated mouse, none of which
have been successful
whatsoever. And what I don't understand is why we keep pushing on down the same road, using the same way of looking at these drugs. And increasingly, I see us sort of grasping at straws, the English expression would be, to try and find a way forward, because everybody seems to be focused these days on cure, as they would call it, neuroprotection, disease modification.
Do you think that the progress in genetics and molecular biology are going to generate better models?
Well, probably the geneticists and everybody else will rush in through the door now and take me out and have me burnt as a heretic or hung outside the Dublin Convention Centre.
So, but what is your opinion?
My opinion is, in the long term, that might turn out to be true. Sure. But I have been disappointed at the way in which the genetic defects have not so far translated into a major advance in producing models for Parkinson's disease.
It's long.
It's a long and hard road, and it does worry me a little bit. But we become very focused in this field on the new things, and we all rush off and we get very excited about one thing. I remember us being very excited about fetal transplants. We're going to solve Parkinson's disease. Well, we're just coming back to a new round of fetal transplants now, some 20, 30 years later. When alpha-synuclein was first described as being mutated in familial Parkinson's disease by Polymeropoulos, it was viewed like the holy grail of Parkinson's disease, and this was going to be our salvation. Well, 30 years later, we're still trying to work out the physiological function of this protein. It's clearly important in the pathogenic process, but maybe it just becomes rolled up however cell death starts to occur. So in some ways there are fads and phases, and I just have the feeling at the moment we're milling around a bit. We're all standing around waiting for the next door to open, and maybe.
Do you think we will be moving back to more environmental factors and combining?
If you listen to my colleague John Hardy, who I respect very much, he thinks ultimately about 50% of Parkinson's disease will be shown to have some form of genetic component. Well, a lot of that, as far as I can see, will be susceptibility to developing Parkinson's disease rather than being directly causal. And I would still keep looking at environmental factors and the role that they have in Parkinson's disease. Don't ask me which area to go in. I mean,
Yeah.
we've trawled through pesticides and other things.
Before leaving animal models, I wanted to ask you, do you have any evidence that the placebo effect is existing in the animals?
It's a very good question. I don't think so. I don't think so. But it's
both expectation and conditioning.
Yes.
And so in an experiment there might be some conditioning.
Yes.
So
it's a very good point. It's certainly true that if you take the 6-hydroxydopamine lesion rat and you give it a vehicle injection, you will get some behavioural response. You'll get some rotational activity and some other motor changes, whether that's because they've had an injection, whether the sharpness of the needle has done that, or there's an expectation. But we have seen things in 6-hydroxydopamine lesion rats where you take them out of their home environment and you put them into a test environment that they've previously been exposed to, and you will get transient rotational behaviour. And you might be right. This might be dopamine being released through a placebo
So
effect.
in all your experiments there is a placebo control?
In all my experiments, there's a vehicle control.
Sure, yeah.
Whether there's a placebo control or not, that's another question.
Okay. If you look within the past 30 years, you said, okay, still levodopa, but what do you think has been the main achievement, and not necessarily just for medications, but observing movement disorder and Parkinson's disease in the past years? What has been really changing?
I can tell you what I see. As you know, I'm not a clinician.
No, but you are well aware of what's going on in the clinics.
I am, and the place I see patients is at patient carer groups, and the biggest change has been the care with which they're being treated, more careful use of drugs, and we've gone from this situation that there was 15, 20 years ago, where I always describe it as looking like headbangers at a rave. The dyskinesia was absolutely rampant. These groups would move and sway in front of you. And now I have to look much more closely to find somebody who's got a significant dyskinesia. It's invariably a young onset patient. I think you guys actually at the coalface, at the front, are treating patients much, much better with better use of the drugs we have available, and that's been a very significant difference.
I would agree, and I think this is also the advantage of these complementary dopaminergic medications that have been available.
Yeah, that's correct, because now you've got the ability to tune patients, you've got the ability to move between various drugs, you've got the ability to use lower doses of levodopa and to combine it with either something that really supplements the activity of levodopa, or you can add in dopamine agonists. But I go back to you, and I'm the one who's supposed to be being interviewed,
Yes.
but I just say, how much more can we squeeze out of dopamine? We have, I think, in my view, to try and find another avenue to open up, because there's a lot of I dotting and T crossing going on. We need a new vista, perhaps, and that's what I'd really like to do, find a new vista for Parkinson's disease.
Could be. Do you still believe in the fact that if we would have a really continuously acting levodopa, that would solve a lot of the problems?
You did review my paper for movement disorders. Clearly, I can tell from these comments. I'll be quite honest about this. I don't think it's going to solve the problem. I think levodopa is inherently a drug that produces the changes that lead to involuntary movements. And we have done some studies at the moment, unpublished, which will come out in movement disorders very soon, which shows that if we take the poor old 6-hydroxydopamine lesion rat and we give it an animal equivalent of duodopa, we can only do this for 8 hours a day in animals. We saw abnormal involuntary movements start just as quickly as they did when we administered levodopa by a discontinuous pulsatile route.
But you might have seen less of problems.
I might have seen less.
But I think that in your animals you have been looking much more on the positive symptoms, which are dyskinesia, which might be interestingly easier to quote and rate than to the wearing off or off problem.
You're absolutely correct. And I've been haranguing my own people in my own laboratories. I've been saying to them, look, it's no good just keep looking at dyskinesia. These animals, we know they have freezing episodes. We know they have wearing off episodes, yet we're not doing anything with this. And some of these are bigger clinical problems. Dyskinesia wearing off, as again you know very well, is reported as being more of a problem for the majority of patients than dyskinesia. So there's fault at the preclinical level. We haven't done enough to exploit what we have, and I also don't think we've taken animal models on to a new level. But one of the reasons for that may be funding, that people don't seem to be willing to put money into just what I would call playing around, looking for a new model. It's very difficult to get people interested in doing that, because the push is to move on. And genetics and molecular science have dominated the landscape for the last 5 or 10 years, and I think that will continue to be the case. And it's increasingly difficult for people doing translational pharmacology to get the funding to do these things.
And to get also the students who are, transmitting the knowledge in terms of, behavior, in terms of in vivo.
Well, this is correct,
research.
Because if we're not careful, some of these things will be dying skills. That if you're not getting enough people coming into in vivo pharmacology, the models part of the illness, which is still at the crossroads that you need to go across to get to the clinic, that will become a lost art. And that's true of many areas of pharmacology already. And even if the molecular and the genetics succeeds, eventually it will be translated into something which has to be tested by pharmacologists in pharmacological models of Parkinson's disease. And if we're still in the same place, this is not going to be what's required. So we have to be prepared for this.
Sure. You've said that, among the works you've been participating or running, the mitochondrial dysfunctions and the proteasome aspects, so all this pathophysiology approach of Parkinson's disease, you were proud of it. Being interested in translational medicine, so up to now, this has not been translating yet.
Nope.
So among your other works, what would you say you are proud or happy that came to the patients?
I think some of the stuff to do with dyskinesia, I'm quite proud of that. The stuff we did in the MPTP-treated primate, some of the early work with dopamine agonist compounds, unraveling dyskinesia, that's been, I think, a source of pride to me. My difficulty is I go out and I talk to these patient carer groups, and they talk to me about things that we're not working on. And that's the sort of thing where I feel a little concerned, because if we could give them a good night's sleep, if we did more work on sleep, if we did more work on pain,
on fatigue,
if we actually did some things, and we actually tried to do this in a laboratory setting, so to give people a clue as to the pharmacological mechanism involved, that might take us forward, and we might have a great effect on quality of life.
Sure. I'm also wondering, what are your views? Where do you think we will, in the next, let's say, 10 years, we should expect major changes or improvement or translation?
Well, my hope is that the molecular and the genetics and the stem cell research and things using gene therapies will yield up something which is then going to be applied to the general population.
Do you think that, with biotherapy, intrinsically, we might be limited to one mechanism of action in one region of the brain, and that's going to be a major limitation?
Oh, absolutely. Absolutely. I listen to some of these things and I think, well, even if they manage to cure the dopamine bit, all the other parts of the brain are going to continue to degenerate. All the non-motor components of Parkinson's disease will still be there. And my biggest worry is maybe the pathogenic work we did hasn't failed to translate in the clinic. Maybe at the clinical level, you haven't divided the patients up into those who have a mitochondrial defect, those who have oxidative stress, and I look at this, and to some extent I blame the industry for some of this, because what they say is, well, if we divide the patient population up and we just cure those with a LRRK2 deficiency, or we cure those with a mitochondrial deficiency, the business case for spending $800 million on developing a new drug is not there. Why should we do this? So in your world, what I see is I still see people putting 200 patients into one arm and 200 patients into another arm, active drug and placebo, overall statistically significant difference between the two. Yet in a neuroprotection study, maybe 10% are better. Would you see that against the statistical background and the way those trials are run? That sort of worries me.
Yeah, sure.
But you're the clinician, so...
Sure, but you are the interviewed. And, well, coming to the Movement Disorder Society, so you are among those who have been, working closely with the founder of the society, who has been, active and participating and enjoying. So what kind of achievements, changes you think the Movement Disorder Society provided? And then what kind of... for your own life, entertainment, pleasure, fun, can you remember within, MDS, which has been now for more than 20 years?
I'm not sure that most of those things I can tell you about.
Well, this is what also letting it to you.
I think the great achievement of the Movement Disorder Society is bringing awareness of movement disorders as a whole to a wider population of individuals in countries all over the world. You've only got to look at this meeting. This meeting's, I'm amazed, there's 5,000 people at this meeting, and you look around, they're from all corners of the globe, and I think I saw some African faces today. I haven't seen many African faces at these meetings before because Parkinson's disease has not been one of their top priorities. But I think that's what it's done. It's created a global community of people interested in movement disorders. And today, if you look around, the other thing is, because I can do this from where I'm sitting, they're young. There's a young population here, and that's really good because it means you're recruiting young people into neurology and neuroscience, and that can only be good for the patient population in the long term.
Just hold on for 1 second or something, I can be quiet out there.
Shh. Shut up. So we're nearly done. But you have to give some kind of funny story for clothing. Think of it. Yeah, it doesn't matter.
Sorry about that, folks. I'm chatting out there. Rolling, yeah.
And well, so you would agree that one can be nostalgic about the time when there were, 80 people working together, being close friends, and having nice exchanges. But inevitably, and I think it's good that the society has been growing up to a worldwide big enterprise, which is educating and which is disseminating the knowledge. But you, in this time when there were, much fewer people involved in the field and everybody knew everybody and had fun, I mean, everybody knows what a kind of a person who likes life, enjoyable, fun, and all these things. And there are many, many funny stories about Peter Jenner in this and this meeting or on that and that occasion. Could you just tell us some of the nice stories that you remember?
I remember some strange things, actually. I remember doing a meeting talking at a symposium that Eduardo Tolosa was chairing, and I clearly hadn't read the papers well because he introduced me in Spanish, and so I got up and I did my talk, and I sat down and he got up and said something to the audience, and then he said, "If only that had been the subject I asked you to talk on." so I talked on completely the wrong topic, and you tend to remember embarrassing moments like that. But I think one of the funniest things that sort of happened to me, which was a bit cruel, was I was in the south of France at a meeting, and a group of us, 19 of us, went out for lunch, and we were getting towards the end of the lunch, and I went to the restroom because we drunk a lot of wine as usual with Marsden-based lunches, and when I got back they'd all gone and they had left me to pay the £937 bill that they'd racked up by drinking and eating. And I suppose, there's other things which I wish I hadn't said, like Stan Farm once invited me to the American Academy of Neurology, whereas, as you know, at the American Academy, people pay to go, and they then have have to pay to come and hear you, and then they have to pay to buy the videos and all the goods afterwards. And so I went all the way, I think it was to Boston, and the American Academy of Neurology offered me $217.11 for the whole of my travel and my hotels. And I said to Stan Farm about this, and I've never been invited back to the American Academy ever again for complaining about this. So, and perhaps that's one of the things I sort of regret. It says on your list of questions, what things would you do again differently? Yeah. The answer is probably I'd be more politically correct. I've never been very political. I've always behind a facade of humour and levity, lightness. I'm really quite a serious person if you dig down, but maybe I shouldn't have been so light-hearted about things and made fun of things. Maybe I should have played the game more and agreed to sit on more committees and not just been throwing rocks from the sidelines at people. Maybe then. Maybe I would have risen to high office in the Movement Disorder Society instead of my only role has ever been to be a member of the Archive Committee.
And now a case of the Archive.
And now a case for the Archive Committee.
Well, before closing, I mean, I know you are lecturing a lot in all over the world and in Asia. Do you have the feeling that for science, the hurt of the stories is moving to the Pacific or not yet? Or how do you?
I think you're absolutely correct. I went to I spoke at the Korean National Movement Disorder Society's meeting in Seoul very recently, and I was really impressed with, first of all, the quality of the neurologists. Many of them having been trained in the UK and the US, the quality of their communication skills in English, but I was most impressed by the quality of what they were doing clinically and their interest in the science base of their subject. And this has been my experience in China, it's been my experience in Japan and elsewhere. And I think we've got to look to these, the countries in Asia for a lead. These are highly populous countries, huge populations, they have growing economies, and I think we have to realise where a lot of the patient population will be living in the future as these communities age and age.
Science is moving there, and then the clinical pharmacology will be moving
there. The clinical pharmacology will move there, and you'll be out of work in Toulouse and looking to move to Vietnam, probably.
Might be. So, well, thanks a lot, Peter. If you said, and I would disagree. I mean, you have always been a special character in the society. Making things funny and innovative and critical in the good sense. So I wouldn't say that you should have changed that behavior. But if you would make some recommendations for the young generation from your experience of that, what would be the main message?
I think get a better life-work balance than I achieved. I was brought up with a very Protestant work ethic. My mother drove me to work, so I'm a typical case for the psychiatrist in blaming my mother for everything. And work was extremely important to her and became so to me. And I think I have focused largely on what I've been doing. It's been my interest in life, but I haven't had much time for anything else. And my recommendation to the younger people would balance it out better. Don't write 800 papers, because you get to a point where the thought of writing another one is the biggest fear in your life. And I think enjoy what you do. If you're enjoying it, it's the right thing for you to do. If you're not enjoying it, go do something else. And never lose sight of your patient population. Never lose sight of the people at the end of the road who are the ones who've got Parkinson's disease, their families, their carers, because those are the ones who need your efforts, and they're the ones who should be benefiting from what you're doing. And it's very, very good to be nice and very academic and very deep in science. But at some point, this has to translate into clinically effective therapies for the people for whom you're working.
I think it's a very nice message. I think this is one of the big achievements and example you can give to them, because you, among the scientists who have been working not necessarily in the clinics. You have been among those who really understood and cared about where and what are the problems to try then to go backwards to the bench. And that's something everybody should compliment you for. Thank you, Peter.
Thank you very much, Olivier. Thank you.